Compared to outsourcing to service providers, or using traditional tools like machining or injection molding, in-house 3D printing can save weeks of lead time when producing prototypes, one-offs, and custom parts. But when it comes to answering which 3D printing technology is the fastest, tech specs and raw printing speed don't tell the full story. You also need to consider how long it takes to set up, print, and post-process the parts to achieve the results you want. To help you find the technology that offers the right balance between time to part and throughput, in this video we'll compare the workflows of the most common 3D printing technologies: FDM, SLA, and SLS. Regardless of the technology being used, setting up the print involves two main steps: file setup and printer setup. During file setup, the user uses a print preparation software, sometimes called a slicer, to adjust settings like part orientation, support structures, and print resolution before sending the design to the 3D printer. Printer setup is the process of getting the printer ready to start printing by loading, changing, or refilling the material and replacing the tank or cartridge if needed. Let's look at the setup process for each technology, starting with FDM. Because FDM 3D printing has more design constraints than SLA or SLS, especially with complex parts, it might require more work to optimize CAD models before printing. On the other hand, setting up an FDM printer is fairly easy in most cases, and changing material only takes a few minutes. SLA printing has fewer design constraints, and preparing the print-in software only takes a few clicks. Setting up an SLA printer is pretty much plug and play, and requires no tweaking, while changing materials only takes a few seconds. Since SLS parts are supported by the surrounding powder, no printed supports are needed, reducing constraints on print geometries. Preparing jobs is also simple, as the software helps nesting and optimizing parts in the build volume. The workflow for setting up SLS printers and reusing powder can seem complex, but the right post-processing accessories will simplify things greatly. Next, let's compare raw printing times. Some printers are faster to deliver a single part, while others are optimized for larger batches. So it's important to choose a 3D printer that balances the time to part and throughput according to your needs. FDM printers usually do not create solid parts, but instead use internal structures to fill up the space inside a model to save time. They also use thicker, coarse layers, which leads to a trade-off between speed and detail. As a result, FDM is a good choice for rough prototypes, but it is slower to produce complex parts with fine features. SLA 3D printers represent the sweet spot for versatility. They are best known for creating watertight, functional parts with a smooth surface finish and fine details. With some new materials, they are the fastest technology to produce quick drafts with thicker layers for rapid prototyping. Print time per part also decreases rapidly when you add many parts in a single build, so SLA is often a good choice for printing bigger batches of parts and for those looking to print with a higher throughput. The SLS 3D printing process generally takes longer, as the printer needs to heat up and the build also has to slowly cool down after printing. However, the SLS process allows for nesting many parts into a single build, and in turn can often be the most efficient way to produce larger batches of parts when post-processing and finishing are taken into consideration. Post-processing is the dirty secret most manufacturers don't talk about, but it massively affects the design-to-finish part time. Post-processing FDM parts can be fast, but only for simple parts and rough prototypes, as more complex parts require support structures that either break away or need to be dissolved in water or using chemicals. Achieving a high-quality finish for FDM parts requires lengthy manual sanding and finishing, which can dramatically affect the dimensional accuracy and form and fit of the parts. SLA post-processing consists of washing the part and, depending on the material and the design, also post-curing and removing supports. Washing and curing can be automated with accessories to save time. Thanks to light touch supports, support removal is quick, and parts have a high surface quality right out of the printer. Overall, this results in slower post-processing compared to FDM for simple parts, but faster for high-quality parts that would require supports on FDM. The powder-based nature of SLS can make post-processing seem messy and hands-on, but the right accessories can go a long way to simplifying the process. The printed parts need to be removed from the powder that surrounds them and the excess material cleaned off. For the best surface finish, bead blasting can be used. Most importantly, because support structures are not printed onto each part, post-processing can be scaled and more easily compared to FDM and SLA. As a result, per part post-processing times for SLS can be significantly lower at scale. As we can see, speed in 3D printing is more than just about how fast a printer can print a part. To be able to compare different solutions with confidence, it's a smart move to get familiar with the entire workflow of a chosen printer or technology, and investigate the from design to finished part time estimates based on your designs and demand.